Okay, everyone. So we're starting the next unit, which talks about quantitative data in chemical reactions. So this is going to play a major role in the rest of this course, and not only that, but the rest of any chemistry course that you pretty much will ever take. So if you decide to continue on in chemistry, you will see this concept be at the forefront. Okay, so it's important that we get a good grasp on this. So the concept we're going to talk about today is something called a mole. So not a mole in terms of, the animal or, something you might find on somebody's skin. So we're talking here about a mole in chemistry. So a mole in terms of chemistry actually is a grouping of items to a certain number. So it's kind of like you're basically associating a number with a word. So it's very similar to if I say the word pair, like we have, a pair of gloves. We have two gloves. Or we have a pair of ears. We have two ears. So the term pair, if you ever see the word pair, it automatically in your mind will go to the number 2. Like that's its number association. The term dozen, right? If you think of dozen eggs, dozen donuts, dozen roses, a dozen anything, always represents the number 12. So, and the same thing can be said with like alterations to this. So if I said a half dozen, right? So if I said I want half a dozen cookies, that would automatically translate into half of the number 12. Like we can use that word to also make alterations. What if I wanted 2 dozen? And I'm going to pre-COVID times and I want to go to a big party and I want to bring a bunch of donuts. I'm going to get 2 dozen donuts. So that automatically will translate to the number 24 because it's 2 times a dozen, which is 2 times 12. So the next word you may or may not have heard of, but a ream, very commonly a ream is associated with, the most common thing I guess would be paper. So when you go and you buy paper in the little bundles that come, let's say at Staples or wherever you can buy paper, that's a ream of paper. So there's 500 sheets in that packaged bundle of paper. So again, it's like a word that's associated with a number. So all of these that we've looked at so far are words linked to numbers. That's exactly what the term a mole is in chemistry. It's a word linked to a number. And that's really the most difficult thing to kind of overcome. So a lot of people think that this term is some weird thing and they don't understand it. It's literally like saying, do you understand that a dozen means 12? Okay, well, a mole means 6.02 times 10 to the 23. Now it's weird because it's a really, really, really big number, but it's still a word linked to a number. Okay, that's all this is. So why do we have to use this word? Like, why can't we just use the actual number? So the problem becomes that when we're looking at samples of chemicals, doesn't matter what it is, and let's say I'm looking at, 5 grams of something. Let's say 5 grams of sugar. Okay, well, those 5 grams of sugar, even though it's not a very big amount, that's like a teaspoon of sugar. There are tons, like billions and billions of molecules of sugar in that teaspoon of sugar. So if we wanted to start talking about how many sugar molecules there are, we have to start combining them and condensing them because we won't be able to keep track of billions and billions and billions of molecules or atoms. So basically this word, we use this word as like a condensed down version. So instead of saying, oh, this has, it has, I'm just going to make up a number. Oh, we have this many molecules of sugar. Okay, well, what the heck? How did we get that? But, but instead of saying we have, okay, this huge number of sugar, it's way easier to say, okay, well, we have 3 moles of sugar, right? It's not as easy as doing this, like 2 dozen. So it's easier to say the word number 2 than it is to say 24, but it's the same idea. I don't want to say this number, so I can use this word to represent the number. Same thing here. I don't want to say this number. I can use the word to help condense down the number. Okay, so that's what this new unit is, a mole. So the symbol is lowercase m-o-l. So when I want to say 3 moles, I can say 3 M-O-L. I know it's like, well, why didn't they just write the whole thing? All they're doing is cutting off the E, but that's what it is. I didn't make it up. Okay? So what can we use the mole for? Well, the answer is anything. Just like you can use the word dozen for anything, I can say a dozen eggs, a dozen roses, a dozen donuts, a dozen whatever. The mole can be used also for whatever. Now, what do we usually use it for? Well, things involved in chemistry. So things like atoms, particles, molecules, ions. So this term formula units, you're going to see this come out quite a bit. It's basically another way of saying compounds. So if I say, how many formula units are there? It's the same thing as saying how many compounds are there. Okay, it's just a different term that's used for the same thing. Okay, so, but remember, technically we can use the word mole for anything, just like I can use the word dozen for anything, and pair for anything, right? A pair of eyes, a pair of, socks, a pair of gloves. You can apply that word to anything. So here are some examples. So a mole. 1 dozen cookies is equal to 12 cookies. Okay, well, 1 mole worth of cookies is 6.02 times 10 to the 23 cookies. It's just a word and a number. A word and a number. Okay? If I had a dozen cars, okay, well, I have 12 cars. I have 1 mole of cars. I have 6.02 times 10 to the 23 cars. 1 dozen aluminum atoms, okay, is 12 aluminum atoms, the word and the number. If I have 1 mole of aluminum atoms, I have 6.02 times 10 to the 23 aluminum atoms. You can use the word and apply it to anything. Now, would we apply it to anything? Well, no, because this is a really, really big number. Okay, look at the number drawn all the way out. 6.02 times 10 to the 23. Remember scientific notation, that means the decimal point has been moved over to the left 23 times. So this is a huge, 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 huge number. But why is it so huge? Because atoms and molecules and particles and compounds, they're all very, very, very small. Remember, like 1 teaspoon of sugar can have so many molecules. So when we're talking about its weight, isn't this way easier just to say the number 1, right? Instead of this huge number. So just to kind of give you an idea of how big this number is, not just like on paper, but just to think about the sheer amount. Let's say we had 1 mole worth of money, a mole worth of loonies, right? So 1 mole times $1, right? A loonie. So the average person lives about, let's say, 80 years, 75 to 80 years. So look at this stat. If you spent $1 billion for every second that you are alive, you would never spend this much money. There's literally not enough, and you're spending $1 billion every second that you're alive. You'll never be able to reach this amount. But that little teaspoon of sugar has so many of those molecules, right? They're so tiny. What about if we had 1 mole worth of Timbits? Well, if you were to pile them up, like just throw them in a pile, it would essentially cover the entire world. Okay, so it's able to cover the circumference, everything, every section of the world is covered in Timbits. And not only that, it would cover the Earth's surface to about 8 kilometers deep. So just to give you a reference on that, let me look to see how many kilometers is the CN Tower. CN Tower height in kilometers. Okay, the CN Tower is 0.5 kilometers. So that's like we have, 16 CN Towers end to end full of Timbits all around the world. That's huge. That's incredible, right? What about red blood cells? 1 mole worth of red blood cells. 1 mole worth of red blood cells would actually, we would not even have 1 mole if we were to add up the total number of blood cells found in every human being found on Earth. And this stat, just so you know, is assuming we had 8 billion people. I know that we do have more people on Earth. I don't know if we have enough to reach a mole yet, but that is huge. And every person's body has tons of red blood cells. I think how small cells are. Every person on Earth, you add them all up, you still don't have a mole. Isn't that crazy? Okay, so I'm going to show you what 1 mole worth of water looks like, just to give you a comparison. Okay, so let's say we had a 1 liter big beaker of water. And then I had, let's say 1 cup of water, so 250 milliliters, 1 cup. And then I had, in a test tube, about half a test tube filled with water, 18 milliliters. It's actually a little bit more than 1 tablespoon. So it's like 1 tablespoon is 15 milliliters. So it's like 1 tablespoon and a bit of water. This is what 1 mole of water particles looks like. So inside, so imagine, take like a, try it. Take a tablespoon of water. A tablespoon of water and then add like 2 more drops, 3 more drops. That is 6.02 times 10 to the 23 water particles. That's how tiny. When we're talking about, when we draw water, we draw it nice and big. We're like, oh, here's a big particle of water. Here you go. It's nice and big. Here's a Lewis structure. But it's so, so, so tiny, right? Think of how many can fit in this 1 little tablespoon and a couple of drops. It's insane. Okay, very small. So where does this number come from? Or I guess I should say, where does it get, what is it called? Okay, so there's a term for this number. So the number that is equal to 1 mole also goes by the term Avogadros number. Okay, so it's named after a chemist. It's actually not the person who discovered it. Avogadro was a scientist, and this is not a real picture. This is a sketch that somebody did of him. This was like a long, long time ago, as you can see by his years. So why did they decide to name it after him? To be honest, I'm unsure. It could be the fact that he contributed a lot of work towards quantitative data. It's kind of like when we name elements on the periodic table after scientists. It's kind of like you're giving homage, like it's the Hall of Fame for scientists to have something named after them in the world of chemistry. So this is one of them. So if you ever see the term Avogadros number, it's discussing this number. That's what that's referring to. Okay? So before we get into molar mass, I'm going to wait for this for the next part.